All right, here's what we have in Section 7.8. In Section 7.8, they're going to give us data. From the data, we're going to find an equation. And once we find the equation, we're going to answer questions about the data. All right, so I'm looking at number 4 here. Number 4 says, a tennis ball is tossed upward and its height at various times are recorded. All right, so we have our data. It says, let f of t be the height of a tennis ball at t seconds. Part A, find an equation for f. So how are we going to find an equation for f? Well, what have we done many times? Okay, we have a couple options. One option is to take 3 points and use the 3 points to set up a system of 3 by 3 equations and then solve that system of equations. That would be one good way to find the equation. But I think what they really intend for you to do in this section is use your calculator. So I think what they intend you to do is type that data into your calculator, into L1 and L2, and then use which kind of regression? Quadratic. All right, so we're going to use our calculators a lot today. So once again, remind me, how do I type this data into my calculator? Stat. Edit. Ooh, look at all those numbers I have in mind. All right, I don't know what those are. I have no idea. Look at all those numbers. I don't know what I was using this calculator for, but I don't want them. Clear, enter. Clear, enter. All right, so I type them in. I have 0, 0.06, 0.12, 0.18, 0.24, 0.30, and 0.36. 1.93, 2.25, 2.51, 2.69, 2.70, 2.54, 2.37. So we type in all of our data. Now what do? Quit out of that first, and then stat, calculate, 7, 5. What would 7 be? 7 says QUART, regression, quartic. What's that? Anybody know? What's that? Not really. Quadratic regression. Quadratic regression has a power of x squared. What do you think cubic regression is? X cubed. What do you think quartic regression is? X to the 4th. So you could have a function with a power of x to the 4th. And then there's other kinds of regressions. If you take Math1215 next semester, you'll learn about logarithms. It's a logarithmic regression. Exponential regressions, you'll do that in Math1225. Power regression. Logistic regression, I don't think we do that one in 1225, but maybe. Sine regression, that's when you use a trig function, you'll do that one too. Anyway, we want quadratic regression. Go down to calculate, enter. All right, now on the test, when you do this problem on the test, the directions will say, find the regression, and then they'll tell you probably round your answer to 2 decimal places. All right, so we would write y equals, our f of t equals, that's f of t, equals negative 16.17 t squared plus 7.07 t plus 1.91. So there would be our regression equation. Okay, then we're going to ask you some questions. Part B, find the t-intercepts. What do they mean in this situation? All right, so if I have an equation that looks like that, that's my answer for part A. How do I always find the t-intercepts? No? I plug in a special number. How do you find t-intercepts? Plug 0 in. If If I'm looking for the t-intercepts, do I plug 0 in for t, or do I plug 0 in for f of t? F of t. If you're trying to find the t-intercepts, you plug 0 in for the other number. So what they're asking us to do there is take 0 equals negative 16.17 t squared plus 7.07t plus 1.19 and solve that equation. Find the t-intercepts means plug 0 in for y. In this case, we wrote the symbol f of t. How would you solve that equation?
Minus 1.91.
Okay, minus 1.91 and then? That really wouldn't do you any good. The only time factoring really helps is when you have a 0 on one side. So if you're going to move the 1.19 over, factoring won't help very much. What other options do we have for solving this equation? What kind of equation is it? Is it linear? No, it's quadratic. What are our methods for solving quadratic equations? We could factor, but I don't think we want to factor with these ugly decimals. We could use the formula. I think that's our best option. The other option would be to complete the square, but again, I don't really think I want to complete the square, not with these ugly decimals. So I think really the only best option here is to use the quadratic formula. T equals. What's the quadratic formula? All right, so once again, you need to have memorized that formula by Monday. If you have not memorized that formula, then you can't use it. Okay, that formula will not be given to you. You must memorize it. All right, so negative b. How much is negative b? Negative 7.07. Plus or minus the square root of b squared. That's 7.07 squared. 7.07 squared, my calculator says, is 49.9849. Minus 4 times a is negative 16.17 times c is 1.91. All divided by 2a. That's 2 times negative 16.17. That's negative 32.34. That's a lot of numbers. I agree. But the good news is you're just pretty much going to use your calculator, right? Not that big a deal. So we're going to have negative 7.07 plus or minus. I'm going to grab my calculator. I'm going to go 49.9849 minus 4 times negative 16.17 times 1.91. And my calculator gives me that answer, 173.5237. But then I need to take the square root of that, don't I? All right, so square root of that answer is 13 point, I'm going to round off here, I'm going to call it 173, I guess, divided by negative 32.34. But that's not particularly useful. I think what would be a good idea would be to take the negative 7.07 plus the 13.173 and then divide and get one answer. And then do the same thing, negative 7.07 minus 13.173 and divide and get the other answer. So let's see what we get when we do that. Negative 7.07 plus 13.173 divided by negative 32.34. So one answer I get is t equals negative 0.19. I'm going to round to 2 decimal places again. And then the other answer, negative 7.07 minus 13.173 divided by negative 32.34. T equals 0.63. Quite a bit of work. Just because you're dealing with these ugly decimals, quite a bit of work. But again, it's all work on your calculator. Nothing that you really have to figure out on your own. Of course, a really cool trick would have been to use my quadratic formula program. Negative 16.17, 7.07, 1.91. My program works just fine with decimals too. Negative 0.19 and 0.63. Got the same answers. That's good. Anyway, so there are the t-intercepts. What do they mean in this situation? So we got those two numbers. T equals negative 0.19 and t equals 0.63. What do those numbers mean?
At that time, the tennis ball was coming down and going up.
Okay, you're close. T does stand for time, doesn't it? So let me ask you the first question. Can t be negative 0.19? No, t is time, right? We threw the ball at time 0. That's when we threw the ball. So can t be negative? No, so that number doesn't make any sense at all. That number right there is model breakdown. Doesn't make any sense at all. What does that number mean? What does that number mean about the ball? Is what? That's when it hits the ground. Exactly. Why is that when the ball hits the ground? Because we plugged 0 in for f of t, and f of t stands for? No, t stands for time. F of t is the y value, which in this case stands for, what does that have to do with the tennis ball? It's the height of the tennis ball. So what we're saying is, when f of t equals 0, that means the ball hits the ground. So the ball hits the ground in 0.63 seconds. That's what these intercepts mean. This one really doesn't have any meaning at all. This one's model breakdown. That one means the ball hits the ground in 0.63 seconds. C. For what values of t is there a model breakdown for certain? Clearly t can't be negative. Okay, but I don't think that's the entire answer. I think that's half the answer. What's the other half? Right, so t cannot be a negative number, so that one clearly is model breakdown. T can't be negative. But I think t cannot be other numbers too. That's true, but I think 2.7 is not quite the right number. I don't think t can go past 0.63. How come t can't go past 0.63? What if I were to take a number bigger than 0.63 and plug it into this formula? Let's just try it. Let's just plug in 1, for example. If I plug 1 into that formula, I have negative 16.17 plus 7.07 plus 1.91. I would get negative 7.19. That's model breakdown. What's wrong with that? And what's wrong with negative there? No, this isn't negative seconds. This would be 1 second. I plugged in t equals 1. That would be negative height. That would say the ball's gone 7 feet into the ground. Is that reasonable? No, what happens when the ball hits the ground? It bounces, okay? So, but this model that we have doesn't include the bounces. This model says the ball keeps going down. So, I think t cannot be negative, but also t cannot be greater than 0.63. Because if t is greater than 0.63, it would say the ball has gone underground, and I don't think that's believable. The ball hits the ground and it bounces. Worst case scenario, the ball's very flat, it hits the ground and it stops, right? But it's not going to go 7 feet into the ground, we're sure of that. D. Estimate the maximum height of the baseball. When did it reach this height? What's that? That's an excellent question.
I was like, the next line says tennis balls. Yeah, but.
So the answer to D is, who knows? We don't have a baseball in this problem. All right, but let's change it to tennis ball. Let's assume they asked for tennis ball. I've done this problem several times before, and I've never noticed that.
Really?
Yeah. All right, so estimate the maximum height of the tennis ball. All right, so using this equation, from the data we can get an idea, can't we? From the data, what does it look like the maximum height of the tennis ball is? About 2.7, okay. So from the data, we know the answer should be about 2.7. How would I find the maximum using the equation? Plug what in? No, 2.7 is not a t number. 2.7 is a height number. It's the y value. I could, but that's not really what I want to do.
Negative b over 2a.
Why negative b over 2a?
That's the vertex.
That's the vertex. Think of the graph of this function. What does the graph look like? Because of this negative sign in front, it's an upside down parabola. Where is the maximum on an upside down parabola? At the vertex. It's usually positive. In this case, it's going to be positive. So, when you're dealing with these word problems and they ask you for maximum or they ask you for minimum, what are they really asking you to find? Vertex. Anytime you see the words maximum or minimum in this class, in this area, on your test on Monday, they're asking you to find the vertex. So, I think what they really wanted us to do for part D is find the vertex. So the vertex happens at t equals negative b over 2a. That's our little formula for vertex. So that's going to be negative 7.07 divided by negative 32.34. I grab my calculator. Negative 7.07 times divided by negative 32.34. So we would say it's going to happen at about 0.22 seconds. So that's when the ball is going to reach the maximum. Now how do I find out how high the ball went? Take 0.22 and plug it in. So I plug 0.22 into my formula. I'm going to have negative, I said, 16.17 times 0.22 squared plus 7.07 times 0.22 plus 1.91. So we would say our maximum height occurred at f at 0.22, which is about 2.68 feet.
That's when it reaches its maximum.
Correct. So the maximum happens in 0.22 seconds,
Okay.
and the maximum height is 2.68 feet. Which is interesting because, again, if we go back and look at the data, what did we say the maximum was? 2.7. Yet according to the equation, the maximum is only 2.68. So what happened? Yeah, does the equation match the data perfectly? No, it doesn't. We never expect it to. So here's an example where your equation gives you an answer that, because it doesn't match quite perfectly, really isn't correct. We know the ball reached at least 2.7 feet. According to our equation, it only goes 2.68. Again, that's the problem with using an equation. It doesn't match perfectly, but it's pretty close. Part E. Assume that, after the toss, the tennis ball bounces on the ground several times. Sketch a quantitative graph that describes the relationship between the height of the tennis ball and the time until the tennis ball comes to rest. What's all that mean? What does it mean to draw a quantitative graph? That means draw a picture, right? Like so. So what happened with this ball?
It started from 0 and then went up 2.7.
Okay, so I threw the tennis ball up in the air. How high was the tennis ball up in the air when I first threw it?
1.93.
It was, according to the data, when I threw it at time 0, the tennis ball was 1.93 feet in the air. So did I throw it from the ground? No, because I was holding it in my hand like so. It was above the ground. I tossed it up. According to our equation, again, not quite the same. According to our equation, how high was the ball when I first threw it up in the air? 1.91, very good. Because that would be time 0. So that might be another question I ask you. According to the equation, what's the y-intercept? And what does it mean? So the y-intercept would mean you plug 0 in for t. The y-intercept would be 1.91. And that would be how high the ball was when you first threw it. All right, so our ball starts up in the air, 1.19 feet. We throw it. It goes up, comes back down. What happens when it hits the ground? It bounces. How high does it bounce?
2.25.
No, I don't think it bounces that high.
Oh.
How high does it bounce? I don't know. It doesn't tell me. I really have no idea. The only thing I do know is that it's not going to bounce up as high as it went originally, is it? Every time, then the ball is going to bounce, it's going to go up, it's going to come down. What happens when it bounces the second time? Not quite as high, not quite as high again. And eventually, the ball stops bouncing. So I think that's what they mean when they say draw. I think that's the best we can do. The ball bounces several times, eventually hits the ground and stays there. Questions about that?